A very good morning, students. Today in Oceanography, we'll be reading about water masses. A water mass may be defined as an extensive portion of the ocean water identifiable from its temperature, salinity or chemical content. In other words, water mass is a relatively homogeneous body of water which can be identified by its characteristics. In defining the water mass in the oceans, the most important properties are its temperature and salinity. It is to be borne in mind that these two properties of seawater determine its density. A clear understanding of the distribution of the temperature and the salinity relative to one another is therefore the basic need to a description of the water masses. Besides, the movement of the water masses related to one another, particularly in a vertical plane, depends largely on density. After going through this lesson, you will be able to understand water masses, TS diagram, water masses of the world. As stated earlier, density of the ocean water is increased by salinity or pressure or by decrease in the temperature. However, the temperature changes have a much greater effect on the density in the tropical areas than in the polar regions. Thus, density, temperature and salinity are very useful characteristics of water in defining the water masses. The concentrated properties of water, because they are not greatly changed by any processes other than mixing and diffusion. There are three important factors that affect the character of the water masses within any particular region. These factors are the latitude, the degree of insulation and the types of currents. Each factor is important in its own way. TS diagram. So, with a view to describe the temperature and the salinity, Helland Hansen in 1916 devised a TS diagram which relates these two characteristics together. In this diagram, the temperature and the salinity may be plotted against each other. The plotted points generally fall on a well-defined curve which is often usually a very straight line in which temperature and salinity decrease together. Temperature T and salinity S observed at the particular depth are represented by single point in TS diagram. If in a particular area of the ocean, several such pairs of observations obtained from other locations and different depths are plotted in a diagram, an arrangement of points along a curve rather than a random distribution is obtained. The TS diagram is a very valuable tool in oceanography. The TS curve helps in scientific preparation of the oceanographic data and is used to detect errors and to make it homogeneous. Incorrect observations can be detected since they fall outside the normal TS curve for that oceanographic area. The curve is therefore reliable criteria of the accuracy and homogeneity. Stations are identical, all values can be checked immediately, but a faulty observation can also be replaced by a more correct value. In this way, it is possible to perform an objective interpolation of values in order to fill the missing data in the observational material. The TS curve is also helpful in the investigation of the problem of the origin and the mixing of the characteristic water masses in the ocean areas. An accurate analysis of the TS relationship in different parts of the ocean goes a long way in the closer classification of the water types of which ocean is made up of. This also helps in the clarification of the formation, spreading and mixing of the oceanic circulation of the deep and the bottom layers. Formation of the water masses. It is on the surface of the ocean that the water retains its original characteristics of temperature and salinity. Any modifications that occur to the TS relationship are brought about by mixing with water masses lying nearby with different characteristics. The mixing may be either vertical or horizontal. As a result of the mixing with the adjacent water masses, TS relationships are changed to a certain extent. However, if we study the rate of change of the characteristics of any water mass, you can easily get an idea of the amount of dilution with other water masses by mixing which is taking place. WUST devised what is called core method by which water masses could be traced by their extreme values of temperature and salinity. A diagram showing the maximum salinity of the water mass near its source may be compared with that of the new position where the original water mass gets modified. The decrease in its value at any intermediate point gives an accurate value of its dilution. Many oceanographers have done commendable work for describing the distribution of the water in different oceans regarding the frequency of temperature and salinity relationships. While Kocherne studied the characteristics of the surface water of the Pacific Ocean and its different areas and for different seasons of the year, Pollack concentrated on the Indian Ocean and Montgomery on the Atlantic and the World Ocean. Types of water masses. Water masses are classified according to Sverdrup, an eminent oceanographer, in the following manner: surface water masses, intermediate water masses, and deep water masses. Remember that some of the water masses have been given different names by different oceanographers. All the surface water masses form fairly close to the surface of the ocean because of their high temperature compared with waters beneath them. Owing to their relatively greater density, they are not able to sink to the deeper parts of the ocean. However, in certain cases, owing to great density, water masses into the bottom of the ocean, and thus deep water masses in some areas are formed. The subsequent movement of the deep water masses of the upwelling in other areas of the ocean occurs to maintain the balance. It should be kept in mind that the upwelling water does not reach the surface but is overlain by a shallow layer of colder water. The description of various water masses found in the different oceans. The North Atlantic Central Water. This water mass is found over a large area of the North Atlantic Ocean. It is limited to the shallow depths. There is a great similarity in this water mass on the western and the eastern margins of the North Atlantic. This water mass must have been formed in the North Atlantic, and the temperature and salinity recorded in it must have been attained when this water was exposed to the atmosphere. In the vertical plane, its temperature and salinity closely resemble the northward diminution of these characteristics in the horizontal plane. The thickness of the water mass is dependent on the currents flowing within it on the surface. It is rather on the right hand side of the currents and thinner on the left hand side of their direction. It is 900 meter thick in the Sargasso Sea, but outside the sea its thickness hardly exceeds 200 meters. South Atlantic Central Water Mass. This water mass is found over a large area. It is similar to its northern counterpart, that is the North Atlantic Central Water Mass, in respect of the Ts relationship. However, as temperature and salinity both tend to decrease to the south of the equator, which is relatively cooler and fresher than the northern one. There is a great similarity between the vertical and the horizontal ranges of the temperature and salinity between 30 degree and 40 degrees south. The southern subtropical convergence occurs in this zone. Water that sinks at this convergence zone moves northward along its correct density surface. This water mass, which extends from the coast to the coast in the South Atlantic, is also shallow in depth. Its depth hardly exceeds 600 meters. That to the north and the south of the central water masses, as mentioned above, the temperature and salinity of the water on the surface are different from those found in the lower latitudes. The Arctic surface water mass is one of the three water masses formed in the North Polar Sea. The other two water masses are the Atlantic water mass and the Arctic deep water mass. The Arctic surface water mass is characterized by low salinity, particularly near the mouth of the Great Siberia rivers. It is very low. During summer months, the ice melts and huge quantity of fresh water reaches the sea. This is why a layer of cold and fresh water overlies the more saline water, which is certainly of the Atlantic origin. The water from this water mass from the Atlantic has a temperature ranging from 3 to 4 degrees Celsius in summer and about 35 parts per thousand in salinity. These values are found between 75 and 400 meters depth. The subantarctic water mass is found at the surface of the ocean to the south of the subtropical convergence in the South Atlantic. From 52 to 53 degrees south latitude, the subantarctic water is found between the subtropical and the Antarctic convergence zone. To the north of this water mass lies the central water mass, and to the south the circumpolar water mass. In the North Atlantic, this type of water is found in a very limited area. Due to mixing and vertical circulation, the subantarctic water is distinguished by relatively low salinity. This water mass surrounds the Antarctic continent. However, in all the southern parts of the major oceans, its characteristics are rather similar. This water mass occupies the largest area in the North Pacific Ocean. However, the Pacific Ocean being the largest of all the three major oceans, its central water masses are of various types. There is a vast area of equatorial water present in the ocean. Its average temperature in 50 degree north latitude varies from 2 to 4 degrees Celsius. It has a lower salinity of 39 parts per thousand at the surface. However, the salinity increases to about 34 parts per thousand at a depth of few hundred meters. Central Pacific water includes the western and the eastern type. The salinity in these waters is relatively lower than their counterparts in the Atlantic Ocean. But the range with respect to the temperature, arid and salinity is almost similar to its Atlantic counterpart. As regards area, western type occupies a larger area than the eastern type. The North Pacific Central water has lowest values for salinity. The equatorial water mass covers a wide zone and separates the central water masses to the north and the south. In the eastern part of the ocean, the area covered by this type of water mass extends from 20 degree north to 20 degree south. Off New Guinea, the area of this type of water mass narrows down to 1 to 2 degree north of equator. This water mass is characterized by 15 to 8 degrees Celsius and 35.15 parts per thousand salinity to 34.6 parts per thousand salinity respectively. The temperature at the depth of 800 meters is 5.5 degrees Celsius. This water mass encompasses the equatorial current system. South central water masses lie to the south of the equatorial water mass area, be divided into eastern and the western type. The temperature varies from 10 to 18 degrees Celsius in the eastern sub-Pacific central water. However, the salinity slightly lower is in the west. These water masses are formed at the subtropical convergence. The Indian central water mass is found in the north extension of the Pacific equatorial water mass in the Indian Ocean as stated above. The Indian equatorial water mass, unlike central water, the equatorial water of the Indian Ocean, is not so clearly defined, but a considerable similarity exists in the T-S relationship as a majority of the stations to the north of the greater equator. At most of the northern stations, the corresponding temperature and salinity value fall nearly on a straight line between the point T is equals to 4 degrees Celsius to S is equals to 24.9 parts per thousand, and T is equals to 17 degrees Celsius and S is equals to 35.25 parts per thousand. Total water mass has higher surface temperature than the central water mass. The spreading of the very saline Red Sea water in the northern Indian Ocean makes the subsurface water slightly modified. At a depth of 750 meters, the temperature and the salinity is of 21.5 degrees to 22 degrees Celsius and 45.5 to 41 parts per thousand respectively. According to Saavedra, the Red Sea water pertaining as a tongue of water of high salinity from a depth of about 500 meters and 8 degree north latitude, the depth of about 1250 meters south of the latitude between Madagascar and the mainland, makes equatorial water highly modified as regards its temperature and salinity. When compared with the central water, the range of the salinity is much smaller in the water mass. The water mass is found between the Antarctic convergence and the Antarctic continent. It is a shallow layer of cold water underlain by a more saline and warmer water. This surface water moves towards north over the water mass that moves in the opposite direction and is deeper as well as warmer. The northward moving surface water mass is 60 to 80 meters deep in the Atlantic Ocean. In the Indian Ocean also, it is as deep as in the Atlantic. It lies in the divergence zone between the eastward and the westward flowing currents. Towards the north, its depth is increased to 300 meters, and towards the south, the depth reaches 400 meters. In winter, its temperature varies between minus 1.8 degrees Celsius and minus 1.9 degrees Celsius in the south, but in the north, the temperature registers slight increase. It varies from 1 degree Celsius to 0 degrees Celsius. The circumpolar water mass, as is clear from its name, encircles the Antarctic continent in the southern latitudes. Within the Antarctic region, a surface layer of low temperature and low salinity is present. The circumpolar water is found between the Antarctic convergence in the Antarctic continent. This water mass is found a little below the surface. The maximum temperature is recorded at a depth of 500 to 600 meters. The temperature is generally about 0.5 degrees Celsius and salinity is about 34.7 parts per thousand. This water mass is characterized by homogeneity throughout the Southern Ocean. Deep water masses. The deep water masses are classified into two categories: intermediate water masses and the deep and the bottom water masses. The intermediate waters, as they are called, are less dense than the bottom waters, so that they can sink to the intermediate depths only. These water masses are found in all the major oceans of the world and high latitudes. According to Sverdrup, at the Antarctic convergence, water of low salinity and low temperature sinks. The North Atlantic intermediate water mass. The North Atlantic intermediate water mass comprises three different types of water masses. Antarctic intermediate water mass, which originated in the South Atlantic. When it enters into the North Atlantic, it mixes with the water mass of this ocean. The Pacific intermediate water mass. The Pacific intermediate water mass formed at about 40 degree north latitude, and it is overlaid by the central water mass of the North Pacific Ocean. Salinity is rather very low in it. The water is found at a depth of 600 to 800 meters in the northwestern part of the Pacific Ocean. However, in the vicinity of the equator, it bifurcates into two layers. One layer is formed at 200 meters depth, while the other is found at 900 meters depth. In these layers, the oxygen is at its minimum in the North Pacific. The Mediterranean water mass. The Mediterranean water mass is relatively dense due to its very saline water. While passing through the Straits of Gibraltar, the salinity is more than 37 parts per thousand. Its temperature reaches 13 degrees Celsius. Intense mixing takes place in the straits. These figures of salinity and temperature are largely modified from those characteristics of the deep water of the Mediterranean Sea. It is to be kept in mind that the Mediterranean water mass exercises a great influence on the deep water, the Atlantic, by adding huge quantities of water of high salinity. The North Atlantic deep and the bottom water, as the name indicates, this water mass can be conveniently divided into two types, the deep water and the bottom water, which have different origins. However, the deep and the bottom water masses are characterized by homogeneity all over the Atlantic Ocean. The deep water originates in the extreme north part of the North Atlantic Ocean, whereas the bottom water is somewhat mixed with the bottom water of the Antarctic origin. The deep water mass in the North Atlantic is found in the region south of the Greenland. This is mixed with the cold water of the Labrador Current and the East Greenland Current. This mixed water mass is cooler in winter, so that its density is increased. Thus, being denser, it sinks to depth exceeding 1000 meters. It has a temperature ranging from 2.8 degrees Celsius to 3.3 degrees Celsius, which varies between 34.9 parts per thousand to 34.96 parts per thousand in salinity. The deep water of the Pacific Ocean. In the northern Pacific, there is no source of deep water. According to Sverdrup, the Pacific deep water is of Atlantic and Indian origin. What has come to become so much diluted by admixture of the intermediate and bottom water that the salinity maximum has disappeared. The Antarctic bottom water mass. This is undoubtedly the densest of all the water masses. The most extreme type of the bottom water found in the Weddell Sea area, where below a depth of about 400 meters, the temperature is dropping about minus 0.4 degrees Celsius and the salinity is about 34.66 parts per thousand. This extremely cold water is the result of very cold water on the surface. Because of the freezing, its salinity registers an increase, and with the result of that, water density is further increased. As a matter of fact, the Antarctic bottom water is formed as an equal mixture of circumpolar water and the shelf water. As you are aware, the concept of air masses in climatology proved very helpful in a clear understanding of the various types of atmospheric phenomena, assisted in the analysis of the weather. So is the case with the concept of water masses. In oceanography, different types of water masses has proved very fruitful in understanding the various types of water movement in different depth levels of the oceans. Thank you and have a nice day.